Okay, good morning. Welcome, everyone. My name is Craig Zamary. I'm a business consultant here at the SBDC at YSU, and we're thrilled to kick off today's session, which is part one of our two-part series on robotics and artificial intelligence. This will be an exciting session, and the purpose is really to help you learn about how robots and artificial intelligence can help your business grow and how to take the next steps and start executing. So before I introduce our guest today, I'd like to provide just some quick outline of the session today. Jeff Legault will begin with a short presentation, and then we'll take just a brief strategic pause and open it up for a Q&A. My teammate, Jenna Binsley, will be monitoring the chat and the Q&A, so please feel free to drop any questions and comments in there, and Jenna will make sure she gets those to our speaker. With that, let's begin. We're super excited to welcome Jeff Legault. He is the Associate Director at Carnegie Mellon University's National Robotics Engineering Center, also referred to as NREC. He oversees several departments and activities, including business development, marketing, recruiting, project financial tracking, and contracts negotiation. Jeff works with the support and technical staff to improve processes and operations and position the organization for its continuous growth. Additionally, Jeff works closely with commercial and government clients to identify problems that can be addressed with NREC robotics, their expertise and technology. Also, under Jeff's leadership, dedicated business development staff, they create and manage new client relationships, and they pursue new markets and applications that could benefit from robotics and create marketing communications programs to build awareness of the NREC brand. So Jeff, at this time, I'm excited to turn it over to you.
Hey, thanks, Greg. Thanks for the introduction. I'm pleased to be here. I tried to go quick. I think I have about 25 minutes to make more time for Q&A at the end to make it more interactive. So two topics I will cover today is how robotics can transform your company, but also how to prepare for it, right? And so, give me a second here. Here we go. All right, so this is a picture of our building. Just give you some information about NREC. We build robots, as you can see. And the unique thing about our building is it's an old foundry, right? It was built in 1898, and it used to build steel pipes in the building. So we kind of reconnect the old-fashioned steel mill out of Pittsburgh and the Rust Belt area to something that is now world-class robotics development. We belong to Carnegie Mellon University, and it has many schools. And what you may not know is that their School of Computer Science is ranked #1 in the world for computer science and artificial intelligence. So it has a very world-class reputation. Within that school, there are several departments. The larger one is called the Robotics Institute, which also is ranked #1 in the world, but for robotics, right? It's very large. It was created in 1979. It has over 900 people, has lots of grad students. So we are a center within that department, but we have a different mission. So as you can see here, we don't have students in our building. We all have staff members, scientists, technicians, engineers. And what we do is we do much higher maturity development, right? And so I'll show you on the next slide what I mean by that. Is this is a scale that the DoD and NASA use called technology readiness level. You can Google it, it's on Wikipedia. So basically at the bottom, you're trying to understand the laws of physics. And here at the top, you are manufacturing, like iPhones or whatnot, right, in volume. So typically universities, academia stays at the lower end. We just come up with new technology, new ideas, new concepts, right? CMU is a little better, and especially the Robotics Institute, they go a little higher and they try to focus more on applications. But where NREC sits here is a unique position that is the only center that we know of in the world that can combine both university type innovation all the way to pre-production system development, right? So we're able to bring innovative ideas all the way to deployment with our customers. So this is it about NREC. Now I want to focus on how can robotics help you as a company. Now, there are multiple ways depending on your industry, but typically come down to these type of areas, right? So it can try to reduce your cost of operations, right? And maybe you have labor challenges, stuff like that. It can increase productivity, right? Multiplying force, meaning that now instead of having one person doing one task, you can have one person supervising 5 robots doing the same task. So more work done with one human worker. Also, you can increase the equipment utilization, meaning that robots don't take breaks. They don't need lunch breaks or need to the bathroom. They also are much less harsh on the equipment. So you have less damage, less maintenance costs, those sort of things. And increase safety, of course, right? There's places you don't want to send humans. It's better to send robots. You don't care if they get damaged. And also it enables new application. So meaning that there are things that it's very hard for human to do. Think of inspecting pipes. It's too small. You cannot send humans into pipes. You can send robots, right? They have tasks. They can do tasks that humans cannot do. And when people think about robotics, they already think about automation, right? And so, oh, we need autonomous. We need to do autonomy. But I want to show here is that this is the typical route to autonomy, right? You don't go straight to autonomous equipment, or you start with baby steps. We start with monitoring equipment, right? You start, then you enhance operators, or you assist the operator to be better. And then you may remove the operator and tele-op certain equipment, right? To make it safer or even more efficient. And then you can move to full automation. And when you have multiple equipment working together, fully autonomous, you have what we call autonomous operations, rather than just an autonomous equipment. And then if you're in the future, you end up with robots fixing robots, and then you can be completely lights out, meaning that there'll be no human in your operations. Everything is going to be automated. And even if something happens, you have robots on site to fix things up. Right? All across these, let's say, route to autonomy, safety is paramount. So all of these steps can improve actual safety in all the way from the low-level monitoring to lights out. Now I'm going to go step by step quickly from all of these steps to give you some examples, right? And these examples will revolve around heavy equipment because we work a lot on that at NREC, but it can translate to many other applications, and you'll see. Right, so think of heavy equipment. So what you can do belt inspection. You can do inspections of these teeth on the buckets, or these drill bits, right? Or you can inspect for the track to make sure it's in good shape and won't break apart, right? So here's an example of a program we did with John Deere. It's actually deployed now. So if you're a farmer, you can buy this as an option on your combine harvester. So there are 2 outputs in a combine harvester. One is the grain, right? And one is the waste. And so we have a camera at each output, and we monitor both the grain and the waste. So you don't want waste going to the grain or grain going to the waste. And you don't want also the grain to be damaged. So we monitor all of that in real time, and we adjust the parameters in real time to keep the machine operating at full optimization, which is extremely hard to do for the operator because it's not intuitive. I mean, tweaking parameters takes a John Deere expert. So this is like you buy a John Deere expert that resides in your machine all the time to make the machine more efficient. This is deployed, fully developed, and it's in sales since 2016 by John Deere. Now switching to the next level, right, is operator assist. The whole point is to make operations safer, but also more efficient, more productive, right? You assist your operators to make a better job, right? Robots can help with that. Here's a couple other examples, right? You can make it safer, right? You can avoid collisions or tip over, or you can make it more efficient. You can help truck drivers to position it correctly the first time and not waste time trying back and forth. Or you can even use it as a training method. You have new operators, they are less efficient than your experienced operators. Well, with machine learning and with robotics, you can guide them so they become efficient a lot more quicker, right? Here's another example with John Deere again in the farming industry. So this is a forage harvester, and an operator typically will have to do 2 things: drive the tractor straight and align with the truck next to it, and with the other hand, maneuver the boom that just dumped the forage into the truck, and you have to move it back and forth and fit it uniformly. It's prone to error because it's too much workload for one human to do all of this at the same time. So what we did is we did a system that automate the boom part. So we didn't automate the equipment part entirely. We just automate one subtask to help the operator. So now the system looks at the truck and decide where to place the boom to fit it uniformly, and even warn the operator, hey, it's almost full. You might want to stop and get ready for a change of truck, right, to continue. So this is all done automatically, but it's to assist the operator, and it's deployed again. It's another system that John Deere sells to its customer at this time. Now, moving to the next level, once you have all of that, then before you can go to full autonomy, you want to have some teleop. Now, you can skip that step in terms of operational, but you don't want to skip it entirely because most of the time it becomes a safety net. So think of it, you deployed equipment somewhere and you have nobody on site. If something is to happen, and it will happen, you have robots getting stuck or don't know what to do, you will need somebody to intervene. And we developed this technology to make it a lot more efficient for a human to intervene remotely. So what we do here is we restart the video. We developed a system that can build a computer graphics model or a gaming environment, right, of the area in real time. So you give the operator an Xbox controller, and now they can drive the equipment, operate the equipment naturally, like if it's just a video game, but it's in real life. So that helps a lot, make it more efficient for humans to intervene if they're not on site. Once you have that and you feel comfortable, they can move to full automated equipment, right? So this is a system that we developed for Caterpillar. It's fully autonomous, right? This was developed for over 4 years, and they've been selling systems since about 2016. So far, they have sold over 275 of these trucks, primarily in Australia. Again, fully autonomous and product level autonomy developed in our center. And the next level is autonomous operations, right? Robots working together. This example is a program we have with the Army, right? So we have drones working together with autonomous ground vehicles to do a mission, which is locate and track this target over here. Right? Again, robots working together into full operation, so you don't need to teleop any of the systems. And then the next level, years down the road, and that's not something you're going to see in your lifetime, perhaps, maybe your grandchildren will see that, is when you have complete lights out. This will require robots like perhaps this one that can fix things up, repair other robots, repair the building, just be able to handle any type of situations. We're not quite there yet, right? Chimp, although it's a very beautiful robot, it's very slow, very expensive. It's just, we're 10, 20, at least 20, 30 years before this becomes mainstream, right? So that's not something you have to worry about so far at this stage, right? So going back to, again, the route to autonomy, as I said, there are many steps going all the way to lights out, and you have to take baby steps. But the key point I want to drive home is there is value to your operations, right, and to your companies at each of these steps. So you don't have to go all the way here, or you don't have to say, I'm going to have to take all these baby steps before I can rip some value out of this. No, we can design, and robotics can help you add value along the way at each step, right? And so that's the point I want you guys to drive home, is you have to start, and even if you can start small, you can still get some benefit out of it. Now, the next part of my presentation is, okay, how to prepare for robotics, right? How do you absorb that? So 3 points I want to make here. We'll talk about, should you be pioneer or follower, right? And also what's unique about the data coming out of robots and how to absorb it in your operation, right? A couple approaches you can take there. First, why invest now, right? Why is it important to do something now? So this is hand-drawn, right? There's no scale here, it's me just drawing that on my screen, right? This is cost of technology going down and the capability of robotics technology going up. We crossed that point more than 5 years ago. So it's already, it's not too late, it's already late, right? We're here today, right? But we're right here today. But even 5 years ago, when we crossed that point, we could solve almost any problems in the industry that you can come up with. Technology can solve it. The question now that we have asked people when they come to us is not, can we solve it, is now, can we solve it in a way that you can make money out of it, right? If you have a task that is complex, technology might be able to solve that task, but it might not be able to do so in a way that you can make money out of it. Maybe the robot would be too costly, too slow, or too high maintenance, we don't know. But technology as itself can solve most problems that we have or we see in the industry today, right? So, and a lot of the experts in the field already all agree that robotics will become the dominant industry in the next 5 to 10 years. So it's something that will not go away, right? We have to embrace it. Here's a extract from a cartoon I took. Basically, the message here is, right, if you're a big company like Apple, you can be innovative. If you're big companies and you have powerful follower strategies, you can be successful. Otherwise, you're a niche player, right? So the question to ask is, you want to be a niche player, you want to be an innovator, right, or a follower? And this brings to a study I saw, which I found very interesting, on smartphones. Basically here, I won't give you the details, but this is like early entry, so innovator, late entry, follower. And the blue area shows that you could have good strategies for both, right? Different strategies, but you can be successful either as a pioneer or a follower, right? That's for smartphones back in 2008. Now, but smartphones is not like robotics for one particular important point: data, right? Because the amount of data that you get from robotics and that you need to develop and to deploy robotics, it's hard to do a me too, because you need to collect your own data, you need to develop very complex technology. So it's really hard to just, I'm going to follow, because the data requires so much time and effort that following takes a lot of time, right? And also, the technology is not a commodity yet, and it requires a lot of different experts. And I'll get to these points in a moment. But just to think about, okay, again, to drive the point, should be a pioneer or follower, right? If you think about traditional technology, think about, I don't know, USB stick or memory sticks, right? A lot of companies will say, okay, I'm going to just improve, absorb the technology, ride the ride, and in the next wave, I'm going to adopt it. So this is like, the blue curve would be like a pioneer, always at the edge of adopting new technology. And as a follower, I can say, hey, I'm going to just wait 2 to 4 years, see how it goes, and follow, right? And I'm going to catch up and just get the same benefit, but just a couple of years later. And that works well for traditional technology. The problem with robotics is the curve is very different. The spacing is much narrower and the steps are much bigger. So if you're going to wait, you decide to be a follower and you want to wait 2 to 4 years, well, you may have too much of a steep step to catch up. It's going to be a disruptive change to your company, because now you have to change everything upside down just to catch up with the industry. So that's something you have to think about: the scale, the rapidity at which robotics increase and grow. It's difficult to catch up. You need to catch the wave now, not to miss it, right? And something I also want to emphasize is AI and robotics is not a commodity yet. So even though you need to catch it, there's still some drawbacks, right? Think of it as the automotive industries in the 1920s, right? Everything was custom. If you bought a car from one company, you had to buy all of the spare parts from that company, and there was no standards. You cannot swap. There's no aftermarket, right, parts available. You're stuck with that company. It's the same with robotics nowadays, right? Because we are in the early stage of this industry. Right. So pros and cons, depending if you're a technology developer, so you want to develop new products in robotics, or technology users, you have things to consider. If you want to develop technology, robotics technology as a product, it's going to require you more investment, right? Unique expertise you need to hire, right? Longer time to market. And you're going to have to reinvent every 3 to 4 years, because the life cycles in robotics, 5 years, things get obsolete. So you need to think about it and always plan to re-innovate every couple cycles. Now, if you want to just use the technology in your operations, stuff like that, keep in mind that it's not plug and play, right? And there's no standards. So which leads that if you have a robot from company A, a robot from company B, they won't talk to each other. They both have their own cloud infrastructure, their own requirements. You're going to have two separate systems that don't communicate or play together. So you're going to have to duplicate your infrastructure to accommodate each of these robots. That's something to think about, right? And think also that at this early stage in this industry, most products are from startups. Well, as you can imagine, startups don't always live long. Some will go bankrupt. So you might buy a product, and 2 years down the road, the company is out and you're left with no support anymore. So all these things need to play into your decision when you adopt new technology as a user. And the next level is thinking about the way you have to think about your company, right? So back in the old days, right, they always said cash is king, right? But with robotics, it's not cash is king, it's data, data and data. Think of Google, Facebook, all of these guys, right? They showed 20 years ago that you can make huge amount of money just on data alone, right? So robotics is the same. And here's why. when you have a robot, it requires a lot of amount of data. It produces a lot of data, right? You have cameras and lidars, and especially if you use like deep learning, which requires a huge amount of data just to train the system. To give you an example here, one robot with just a couple cameras and maybe a couple lasers, right, will produce about 10 terabytes of data per hour. So 1 terabyte is 1,000 gigabytes, which is 1,000,000 megabytes, right? And so that's just for 1 hour for one robot. Now, if you have a couple of robots and you operate them years long, you're going to get into the petabytes in a matter of weeks, right? And so your company needs to be able to deal with that, because data is king, and you want to keep the data because you can use it for a lot of valuable benefit to your company. Now, the third part of this last segment is about how to absorb the technology. And this is more focused on if you want to develop new robotics products, right? You say, I'm going to start developing my own robotics product. There's pros and cons, right? And the main 2 points I want you to remember here is this. If you internalize the technology, let's say you're an established company, you're a GE, you're right, or even a mid-sized company, and you say, I'm going to start my own robotics product. Well, depending where you are, it's going to be difficult to hire robotics talent because they are focused or concentrated into only 3 or 4 areas in the US. I'll show you my map later. And you're going to just have standard valuation, right, for investment. While if you go the startup route, you may establish it in a robotics center like Pittsburgh or Boston or the likes, and you will get possibly a much better valuation for investment. Think of the difference between Tesla and GM, right? Tesla is valued more than GM, but GM produce at least 10 times, if not more, vehicles than Tesla, right? Because GM is seen as a traditional manufacturer, Tesla is a high-tech company. So it's called a PE ratio, right? The profit to equity ratio is a lot different. Also, other things to think about, whatever you're a developer or a technology user, these are the things you need to think about when you want to install technology in your operations or develop technology robotics products. So you're going to need to invest in your IT. There's no way around it. Data will be so much, you need to invest in that. You need to plan ahead. It's always changing, always new things are coming up. You need to be ready. You need to look for what's coming up all the time. Always assume that whatever you buy or invest will be obsolete in 5 years. So don't try to amortize your new robots over 10 years. It'll be obsolete in 5 years. We want to renew it and buy something new and better, right? And think outside the box. And I'll give you one example about that. Okay, here's how to think outside the box. This is an old picture I took on the web. I don't know when it was, but I'm guessing 30s or 40s. People are manufacturing stuff, right? Now, the conventional thinking is, oh, if we're going to change that for robotics, we're going to just replace humans with humanoid robots. That's the wrong approach, because robots, like humanoids, are way too complex, way too expensive, and way too slow. So the way we work is we always look at the job and try to come up with different approaches onto implementing robotics, but in a way that is efficient for robots and not just trying to replace humans. So that's what I mean by think outside the box. Don't think, oh, I'm going to just replace my humans with a robot, a manipulator, and do the same task. No, you need to step back and work with experts that understand robotics, and it can guide you into what's the best approach to come up with the same result, but that's something that is easy to do for robots, because replicating humans, trying to do what humans do, is really hard for a robot to do as of yet. It's going to take another 20 years or more before human robots can mimic humans more perfectly. So, conclusion is there's one thing you should remember today, is that robotics is in the future. It's not going anywhere. So you cannot ignore it, right? You just cannot just simply look the other way around and wait that it becomes a problem. So some of you might be a little bit anxious as, okay, what should I do, right? And I have a couple of recommendations for you. So first, start planning now, right? It's not too late. It's late. I mean, it's not, but it's not too late. So start now. You might want to hire someone with expertise in robotics to guide your company, right? To somebody you trust in your company that can guide you make decisions. You may want to engage with robotics and AI centers or departments at universities, right? To get some expertise to help you as well. one thing that we do, and I'm sure that others do as well, you can fund a technology development or implementation roadmap, right, at Robotics Center, right? So that would help you have a vision that is, or by experts, right, of what would fit your operations in terms of how to implement robotics in times, what you should do now, what you should do in 3 years and 5 years and 8 years, right? And if you don't think you can fund it by yourself, you can team up with your friendly competitors if you want, just to in your industry. So you have a roadmap that adapts to the entire industry, right? And one thing that would be essential is to team up with like groups like the SBDC, because robotics is still very expensive and will require investment. And there, I think there's a lot of role that the state can play in supporting the industry to come up with the next technology to migrate toward robotics in your operations. So this is my last slide, and we'll take questions. Just to show you the map here, so there are 3 areas of robotic centers in the country, right? So the West Coast, of course, you have these giant companies, and then 2 on the East Coast. They are all around universities. So the West Coast, which is primarily AI, there's not much hardware there. It's around Stanford. Now, the Boston region has a lot of companies. It's around MIT, and of course, Pittsburgh, it's around Carnegie Mellon University and NREC and the Robotics Institute. Now, of course, at Pittsburgh, we claim that we are the largest center because we have the largest number of companies. We have more robotics companies in Pittsburgh than Boston, right? Now, this, again, this is larger in terms of scale, right? But it's primarily AI and software, nothing more hardware or manufacturing. So you have that in your backyard, so you should certainly try to take advantage of it, right? And with this, I will stop here and take questions.
Well, Jeff, thank you very much. That was an excellent presentation. I took a lot of notes, and especially to see the impressive work you've done with John Deere to Caterpillar to the U.S. Army, and specifically how you talk about solving problems for companies and how many of those companies turn around and actually sell those to their customers. So, and as well as your approach about starting small. So again, this is a great presentation to help open the eyes of our clients and our guests. So thank you. So as you mentioned, this is a good time for us to take a pause here. I'd like to turn it over to Jenna and see if there's any questions or comments from our guests.
Yeah, sure. So one of the questions we have here says, are there some ways, what are some ways a small business can start working with your office?
So so because we are part of a university, we have certain ways we can engage. One of the ways that we typically start with a new small business is doing a study. So we look at your operations or your product portfolios, and we work with you to establish a plan how you could implement a robotics technology, understanding your customers or your own applications and figuring out what. So we bring the expertise of where we think robotics can fit best, and you bring the domain expertise about your operations or your customers. And so we match those 2 together to build together a roadmap of how you could use robotics in steps, in these baby steps, right? Then the second way to engage is among these baby steps, if there are things that would require custom development, we offer full custom development services. So that's what we do most of our activities around, is developing custom solutions to solve problems, both for the government or the industry, which typically is half and half. So we do a lot of industry projects, solving hard problems, coming up with custom robotic solutions that are ready for deployment, right? So that's the 2 types of services we engage with companies.
Okay, and then I think you kind of answered it there, but there's another question says, do you have any other services you offer to companies as well?
Now, these are the 2 primary services. On the side, individuals, researchers can offer also consultant services. Typically it's done outside of CMU, but or senior researchers, if you just need somebody for a couple hours and they have free time, they are allowed by university to consult with industry, right, on their spare time. So that's something else that we can offer as well.
Okay, another question too. It says, as an industry, how fast is robotics growing?
It is going extremely fast. Again, if I go back to my statement where I think of robotics like the automotive industries in the 1920s, except here we have so much technology, it just ramps up really fast. I'll give you one example. 8 years ago, it was not even conceivable that we could, well, it was really hard just to detect humans, right? And let's say in a farm, you're in an orchard, and detecting humans wearing camouflage was really, really hard. Now, 5 years ago, we solved that. 2 years after, not only we can detect human, we can also track limbs, fingers, and face, and detect left to right and back. And so now we can track all of the motions of humans. It took 2 years from, hey, it's almost impossible just to detect humans versus the surroundings, to, hey, now we can see what the human is doing. So this is how fast this is evolving. And it's coming from the hardware, like the sensors, the computing power that is increasing, and also the algorithms that is evolving. And also AI plays a big role. With AI, we can accelerate development because it's like having thousands of engineers optimizing your algorithms at the same time. So all of these play a role in accelerating the growth of robotics in terms of performance and capabilities.
That's great. And then we do have a question from the audience that says, how do we engage the Institute regarding STTR partnering?
Yes, so we can do both SBIRs or STTRs. Of course, STTRs are more favorable for universities. We just need to discuss, you reach out to me and we discuss what your application is, and I try to find a faculty or researchers who is interested in that topic, and we try to come up with a project together, right? We've done STTRs. The downside of STTRs is that typically funding is limited. So it's for smaller, lesser complex applications. Some complex system would require investment that is beyond the STTR itself, what typically they fund. But some applications fit very well within STTRs, and we have done some of that. So the starting point is really contact me, and we'll discuss your applications and try to find a faculty who can work on your project as a partner for your STTR.
Okay, and then one last question too we have here. It says, what's the wake-up call to companies when it comes to robotics and AI?
The wake-up call is that it's not going away. It's going to be everywhere. So I made a link with the automotive industry, but that's one industry. What's different with robotics is, first, we're in the area where technology moves fast, but also robotics will be everywhere. Robotics will help all of the industry, whatever it's pharmaceutical, manufacturing, and whatnot, right? Or chemistry, or chemical industries, all of these industries. So robotics would be omnipresent everywhere. So that's why it's going to become dominant. And so whatever industry you're in, if you ignore robotics, it's turning away to what's coming up. And so my recommendation is you have two choices. You either try to ride the wave and be on it, or you're going to watch it pass in front of you, you're going to miss it, right? So that's the wake-up call here, is it's going fast, it's already late, it's not too late, but it's not going away, it's going to just get bigger, bigger, and bigger. So you should start thinking about it now.
Okay, and I think that wraps up our Q&A section there, Craig.
Thank you very much, Jenna.
Pleasure.
Jeff, I would like to end by saying that we truly appreciate taking the time to help our attendees today to learn more about robotics and AI. Special thanks to Carnegie Mellon University's National Robotics Engineering Center and your team there. I'd also like to thank on our end, Jenna Binsley, for designing all the digital materials, and Cody helping to set up this session today, as well as Pat Weiss, the director of our SBDC, for having the program available for our clients and others. So thank you to everyone for attending today. Please join us as well tomorrow at 10 a.m. Our session there is going to be titled Drive Business Success via Robots. And the focus for that session tomorrow at 10 a.m. is to learn how and why U.S. companies can manufacture robots right here in the U.S. So again, thanks everyone for attending. Really, truly enjoyed this session with you, Jeff, and wish everyone a great day.